Welcome to Digital Technologies. For today's objectives, we are going to demonstrate the parts of a breadboard, create a simple circuitry, and identify common mistakes when using the breadboard. Let's begin. Breadboard leads and spring clips. The breadboard is loaded with spring clips and are tightly closed to keep the leads of small electrical components in place. Rows and columns. In our example, the breadboard is numbered by rows and alphabetized by columns for easy navigation. This is important for us learners for when building a circuit using a breadboard. Instruction manuals has codes on where to insert the leads of an electrical equipment. If for example the guideline says to insert a jumper wire on C7 and D20, then we must be able to locate C7 here and D20 right here. It's like navigating the multiplication table back in elementary. Power supply buses. The breadboard is equipped with two columns on the right and other two columns on the leftmost part for the buses. Negative and positive buses where power is inserted and grounded. Positive voltage bus. The power, positive or voltage bus is colored red and labeled with a plus sign. This is the cathode connection. Also remember that as a precautionary measure, breadboards are suitable for DC power, and even if AC power can be used under the guidance of a professional, it is highly not recommended. Negative or ground bus. The anode connection is made on the ground bus. It is labeled negative or minus and is usually colored black or blue. Equipments for a breadboard. The breadboard is only compatible on small electrical components that has leads on them. Other electrical components with leads that are bigger than the whole of a breadboard must be connected to a jumper wire first to convert its ends. Usually, bigger electrical components carry higher electrical power, which isn't suitable for a breadboard simulation anyways, so it is rare to use one. Jumper wires. Jumper wires are very relevant on breadboard application, for they are the transport mechanism of the circuit. Imagine this breadboard as a city where the electrical components are the different sectors of an industry and jumper wires are the roads, which is very necessary for the efficiency and effectivity of that industry. Jumper wires must be used accordingly as they might cause short circuits or be placed in the wrong location. Sample application. And now for our application, we will be making a touch doorbell which requires human touch to activate a buzzing sound. Let's begin. For this project, the following materials must be acquired: a 2N2222 rated transistor, one LED of any color, a power supply or battery between 5 to 9 volts, a DC buzzer, 1 kilo ohm of resistor, 4 sets of insulated jumper wires, a pair of insulated jumper wires for breadboard to power supply, and a pair of uninsulated jumper wires. The set of holes along each lines of the buses are interconnected. Our first component would be the transistor. Place the transistor on the breadboard as shown. Connect the emitter to the negative rail using an insulated jumper wire. Next, connect an uninsulated jumper wire to the base and the collector. Connect the negative VE of the buzzer to the collector by adding one jumper wire first. Note that the negative VE of the buzzer is the shorter side, and this is also true with the LED. Add the LED by connecting the negative VE to the collector and a resistor on the other end. Connect the positive VE of the buzzer to the positive rail. End the circuit by placing a connection between the resistor and the positive rail. Prepare the power supply. Use the jumper wire with a lead and socket end. Insert the lead ends on the positive and respective rails and locate the positive and negative leads of the power supply
and insert the sockets on their respective place. Be sure to insert the positive rail to the positive lead of the power supply and do the same in the anode part as well. This is meant to be a touch-sensitive doorbell. Probably my hands have too much resistance for the electricity to travel through. We might need a larger voltage next time, but by using my metals of the scissors, this experiment proves to be successful.
Before ending this video, let us first consider what are the common mistakes that technicians do when using a breadboard.
Getting row numbers wrong.
Getting row numbers wrong can either short-circuit or prevent flow of electrons at all. It is important to carefully check every lead positioning in the breadboard, as this can damage electrical components, especially when dealing with high DC voltages.
Getting power and ground mixed up.
Getting the power and ground mixed up is dangerous, as this can damage the power supply, especially if the power supply is to release great DC voltage. Getting the power and ground mixed up is still expected to induce short circuit or prevent electrons from flowing where they should be.
Not pushing leads and wires in all the way.
Not pushing the leads all the way down breaks the circuit and thus prevents the successful functionality of the device. It is also important to ensure that the leads are clipped well in order to prevent losing electrical components during motion.
Putting components in backwards.
A lot of electrical components process electrical signals one way, like the transistors, diodes, and many more. If these components are installed backwards, there is a great possibility that it will burn out, especially when dealing with high voltages. It is important to check guidelines on how to install an electrical component and review the installation of every component before inducing power.
Short circuit.
Short-circuiting is inevitable in making electrical devices, but its consequences might be irreversible, and to avoid that, the electrician must carefully check installation for any bare metal on the surface that may induce short-circuiting, especially in complex breadboard projects where a lot of wires and sensors may touch each other. And if possible, inspect the circuits with a meter tester and avoid using bare metal wires to avoid unwanted contact of electrical components. That's it for today. I hope you learned something new. Thank you for watching.